tutorial class. This is an online session. This afternoon, we shall be talking about set theory and polynomial equations. I want to talk about set theory as well as polynomial equations. So we start with set theory. I want to believe that the students are very much available here now because we don't have much time to waste. And so the earlier we the better. So this afternoon, we want to look at some text and exam related questions, which will prepare students for challenges ahead as regards their tests and exams. Now, we start with this very interesting question, where we have use this below to answer the following questions. We have the set x is equal to x such that x squared is equal to 9, 2x is equal to 4. Y is a set such that x is not equal to x, and z is equal to a set of x such that x plus 8 is equal to 8. We have to find if x, y, or z is an empty set. Now, there are two major forms or two major ways of representing set. The first one is called tabular form. And what do we mean by tabular form? Now, by tabular form, we mean listing all the elements of a set and separating them by comma with braces to enclose the elements of that set. But in the other one, which is called builder form, builder notation, the properties that the element of that set shared will be defined in the set. So now it is that property that they all share that will be used to list the elements of that set. Now, how do we go about this question? Okay, let's look at the first set here. The first set is x such that x squared is equal to 9. Now, if x squared is equal to 9, what does that imply? If x squared is equal to 9, what does that imply? It implies that if you find the square root of both sides, that is the square root of x squared and the square root of 9, this will imply what? The square here will cancel the square root. You have what? X is equal to plus or minus 3. Okay, that's the result for the square root of 9, plus or minus 3. Now with that, the next statement now said 2x is equal to 4. That means that if we pick any of the values of x here and multiply it by 2, the result must be equal to 4. Let's take. Now, our x is now what? Minus 3 or plus 3. So let's now pick minus 3. That is 2 times minus 3. 2 times minus 3 is what? Minus 6. Is minus 6 equal to 4? No. Let's check the other one. 2 times plus 3. Is plus 3 times 2 equals to 4? This will be 6. No. Since the result here, because the elements of these sets are minus 6 and 6, since the results of the elements being defined by this builder notation form is not equal to 4, it's not satisfied. The property is not satisfied. The first property says the square of that element must be 9, which we have gotten. But the next property now says if you multiply 2 by the element you obtain here, the result must be 4. But unfortunately, the result we get is not equal to 4. So that means set x is an empty set. So this is the symbol of empty. You use set x is empty, or you write it like this. Set x is an empty set. I hope that one is understood. Are we following, please? Are we following? Oh, you cannot see. Okay, let me rewrite that. Let me rewrite that so that you're able to see clearly. Okay. The board is not very broad. Let's rewrite that. Let's rewrite that. Let's write it here. Okay, let's write it here. Now, what are we saying? The result we obtain here is x is equal to minus 3 or plus 3. So multiplying one of the minus 3 by 2. 2 times minus 3 is equal to minus 6. Or multiply the 3 plus 3 that you have by 2. 2 times plus 3. That is minus 6. You observe that the element you obtain here, we have two elements. The element of this set are what? Minus 6 and what? And 6. But we are told that the result must be equal to 4. And none of these results give us 4. So that implies that what? X, the set X is what? It's empty. The set X is empty. That is that about that. The set X is empty. It's an empty set. Let's look at the second set, the set Y. What are we given as Y? Oh, I've cleaned that. Let's look at Y. Okay, Y is a set of X such that X is not equal to X. Okay, that is Y. Y is a set of X such that X is not equal to X. All right. I hope you are following. I hope you are following. Hope there's no problem, please. All right. Now, okay. Let's look at this. Let's look at this. X is not equal to X. How will X not be equal to X? How will X not be equal to X? Is that possible that X will not be equal to X? Is that possible? That is not possible. X must be equal to what? Must be equal to X. So this is also an empty set. This is also what? An empty set. X must be equal to X. So for that statement that says that X is not equal to X, that means that set is also what? It's also empty. It's also what? It's also empty. I hope you are following. Please, if you are following, let me hear yes. Type yes, please. Type yes if you are following. Type yes if you are following, please. Type yes. Hello? Are you following? Are you following, please? Type yes. Hope there's no network problem there from your hand. Any network problem? Okay. Now let's continue. Since there's no problem, then let's continue. Okay. Now let's look at the third question. The third question says we have a set Z such that the element they are X such that X plus 8 is equal to 8. X plus 8 is equal to 8. How does that apply? Yes, let's look at that. X plus 8 is equal to 8. Okay. Now, you can say that Z has elements. Picking up the property here is X plus 8 equals to 8. So we can say X plus 8 is equal to 8. So if we take 8 to the other side there, we have what? This will imply X equal to 8 minus 8. And that will be what? 0. So that means this set, the set Z, has element 0. So the element in that set is 0. So this is not empty. It is only set Z that is not empty. Other sets are empty. Other sets are empty. Please, are we following? Hello? Can you type yes if we are following? Can you type yes if we are following? Can you type yes if we are following? I can't see you typing yes. Type yes if you are following, please. I hope there's no network problem from your hand there. Type yes if you are following. It seems some have not joined, so some are joining behind schedule. Or it's somehow earlier that we joined. We started earlier, so I'm expecting other students to join fast. Please join us. Join us. It is time for you to join. Are you following? Shall we continue, please? Shall we continue? Shall we continue? All right. Let's continue while others meet us there. They join us as we continue. Now, let's look at another very interesting question. See under set theory. Let's look at another interesting question. set theory. Let's clean this. The universal set, the universal set, the universal set, the universal set U, the universal set U of integers A, B, and C are subsets of U defined as follows. We have the universal set U having the subsets A, B, and C as follows. A is a subset that has these properties. A has the following properties. That is, A is a, if you look at it very well, you see that A is a set of even numbers from what? From negative even to positive even. They will also have B such that X is an element such that 0 less than equals to X less than equals to 9. Then we have C, which is a set that contains X such that -4 less than X less than equals to 0. Now the question, let's write the question here. Write down the first question. Write down the sets A complement, that is A prime is the A complement, call it complement of A. Complement of A with respect to U, that is the inverse set. Then we have B. Find B intersection C. Find B intersection C. Hello. Are we together? Let me see you say yes. If you are together here, please type yes. Type yes if you are together. If you are following, type yes. If you are following, type yes. It seems there is a network problem here. The students are not communicating. I think there's a network problem. There's a network problem somewhere. I expect the student to be communicating. Are you following? Are you following? Are you following? Okay. If you are following, say type yes. Let me see yes. Let me see yes, please. Let me see yes. Okay. All right. So now we have, that is question B. And the question C says, find the members of the sets of the set B union C, A intersection B, and A intersection C, and hence show that, let me write this one here. Let me write this one on the top. Okay. Let's solve the problems. Let's solve A and B first, and we continue with the question for C later. Now, the universal set U of integers A, B, and C are subset of the universal set U, defined as follows. A is a set. You can look at, if you look at A, you see that A is being defined with a property. The properties of set A is that they are all even numbers. You can see that they are all even. They are divided by 2. They are divisible by 2. So that means that all the elements in A are even numbers. You can see these three dots before the first element here means that there are other numbers that we cannot list them all. They are endless. The list is endless. And after the 6 here, it also means that the list is endless. So obviously, it's a set of all even numbers, both negative and positive. Now let's look at B. B is a set of numbers such that 0 is less than equal to x and x is less than equals to 9. So we can start. Let's list, because the element of list B can be listed. So let's list the element of B first. The element of B can be listed because they are finite and they are definite. Okay, let's list the element of B first. Now the element of B has the following elements. It has to start from 0 because we are told that 0 is less than equal to x. So it starts from 0. Then we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, we have 9. Why? Because we are told that it starts from 0 and ends at 9. This less than equal to means it ends at 9. This less than equal to here means it starts with 0. Okay, so the element of this set B is that. The element of set B are these. Okay, now the element of set C. Let's find the element of set C. We have x such that -4 less than x and x is less than equal to 0. That means the element will stop at 0. You start with -4. Oh yeah, -4, -3, -2, -1, then 0. Okay, so the element of set C are this. So we have listed the element of set C. Now, what is the question? Write down the set A complement. Fine. That is element of sets that are not in A. Element of sets that are not in A. Beautiful. Now, obviously, we know that A, B, and C are subset of U. They are subset of the universal set U. Good. Now, the elements of A, like we have explained, they are all even numbers. They are numbers that are divisible by 2. So the complement now, A complement will be the elements, that are not in A, but which are in the universal set. And the universal set contains elements that are divisible by 2 and elements that are not divisible by 2. So you can say that you can write, let's say just dot, dot, dot. You can start with -3. You can start with just any odd numbers. Let's say -4, -4 is not hard. -5, -3, -1. You get it now? Now 0, then 1, 3, 5. You can't list them all. Dot, dot, dot. So these are the complements of A. That is elements that are not in A, but which are in the universal set. Since elements in A are even numbers, so A complement will be odd elements. That is numbers that are not divisible by 2. And since they are the list is endless, so the list is endless. You cannot list all of them. You can start with dot, 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 telling us that we have some other negative elements to the left, and you end with dot, 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 telling us that we have some other negative elements to the right. So that is that about the first question. Now the second question. We are asked to find the B intersection C. That is elements that are common to B and C. That is the meaning of B intersection C. Elements that are common to B and C. Let's look at that. B intersection C will be, we have B to be this and we have C to be this. What are the elements that are common to B and C? 0 is common. Fine. What other elements are common to B and C? Nothing again, because all the elements of C are negatives except 0. So the element that are common to B and C is 0. Is 0. I think that is clear. Good. Now, the last question there says, we should find the members of the set B union C, A intersection B, and A intersection C. Now, let's find those one first. Let's find those one first. For C, B union C, that is a combination of elements in B and C. Not common now, a combination. B union C, this union, not intersection. Okay, we can start with negative elements. Then we can start with the negative element. Okay, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, that's it. These are the elements that are what? That are in B union C. Let's write this, but let's write it well in a better form so that we're able to see. Let's write it here. Let's write it here. Question C. B union C will be elements that are in B and C. You start with the least element, -4, -3, -2, -1, 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the elements in B and C. Now, elements that are common to A and B, that is A intersection B. Elements that are common to A and B, that's meaning of A intersection B. Okay. A intersection B will be, oh yeah, let's look at it. Okay, our A are what? They are even numbers. Okay. Now, those are common to A and B. We have 2. We have 2. We have 4. We have 6. We have 8. So these are the elements 2, 4. Do we have 0 there? Yes, I think 0 is there because when we listed them, we have 0, 2, 4, 6, 8. These are the elements that are common to B and C. I'm sorry, A and B. A, they are set of they are set of what? They are set of even numbers. Then B, we have 0, 1, 2, 3, 4, 5, 7, 8. So 8, 9. So the even number here is 2, 4, 6, 8. So intersection, we have this. Okay, now A intersection C also. A intersection C. Let us write that one here. A intersection C. Elements that are common to A and C. Let's list them. Remember, elements in A are, they are what? Even numbers. Okay. Now intersection C. Intersection C is only 0. It's only 0. It's only 0. So what is now the last question that we were not able to write? We are able to show that A intersection B union C, we are asked to show that is equal to A intersection B union A intersection C. Yes, that is what we are asked to show. That's what we are asked to show. We are asked to show that A union B intersection C, is equal to A intersection B union A intersection C. Yeah, let's look at it if we can show that. Now, B union C, what did we get for that? I think I will have to clean some here. Yes, let me clean this one. B union C. B union C. Let's find out what B union C is first. A is a set of what? What? Even numbers, both negative and positive. Oh yeah. And B union C has this. So we have A. So we can say A intersection B union C will be a set of, oh yeah, we have -4, -2, 0, 2, 4, 6, 8. Yes. These are the elements of B, A intersection B union C. You know this B union C. Now the elements in B union C that are common to A, these are the elements. Okay. Now let's look at let's call this one equation 1. Let's look at A intersection B. Let's write that here. A intersection B. Do we still need this? No. A intersection B. A intersection B. Yeah, A intersection B is a set of, A is what? Set of even numbers. Intersection B, if you have 0, beautiful. We have 2, we have 4, we have 6, we have 8. Fine. Okay. Now, A intersection C. A intersection C. Oh yeah, remember A is a set of what? Even numbers, both what? Both what? Negative and positive. We have -4. We have -2, yes, and we have 0. Beautiful. Now, let's now write them together. Let's bring them together. Let's write them together now. Whether they will be equal in result to what we obtain in equation 1. Oh yeah, let's write. Oh yeah, A intersection B union A intersection C. Let's bring everything together. We start with what? The least one. -4, -2, 0, 2, 4, 6, 8. Let's check whether this result is equal to this. Is it equal? Yes. So our result is equal. That means we are correct. So the answer is what? Is correct. Now, let's continue from here. Since we are correct, we can move on. Moving on. Let's move on. Now, list the elements of the following set. This is another question. List the elements. This is another question. List the elements of the following sets. Of natural numbers. Let me write this one here. Set of natural numbers which are 1, 2, 3, 4, and so on. Okay. The first one, A is a set of X such that X is a natural number. Then 3 is less than X and X is less than 7. Don't forget, this is builder notation form where the properties of the set elements are defined. B, we have set B, that is X is as an element, that's the meaning X is a natural number such that X is even. And X is less than 15. X is less than 15. Okay. Now the third one, C, the question C. C is also a set X such that X is a natural number. Then 4 plus X is equal to 3. Now, 4 plus X is equal to 3. Let's look at this. We are asked to list the elements of the following sets. Okay. Now, what we are doing here is we want to actually show that the properties of builder notation is either well defined or not as regards each set. So taking the first set, we are told that X is an element in that set. X is a natural number. 3 is less than X and X is less than 7. Fine. For x to be a natural number, x cannot be negative, of course. So the elements are 3 is less than x. The next number that 3 is less than is 4. Then 4 is also less than 5. And 5 is less than 6. Invariably, 6 is less than 7. So the element of set A are 4, 5, 6. You see that it has satisfied this particular condition. I mean, this property. That 3 must be less than any of these elements, and any of these elements must be less than 7. That is that about that. I hope that is clear. If that is clear, please let me see you type yes. If you understand this, please type yes, please. I want the feedback from you. If you understand this, type yes. Type yes. Let me see you typing yes. Hello? Do you understand this? Type yes. Type yes. I want to see you typing yes, please. Oh yeah. Oh yeah, let's go there. Let's go there. Type yes if you understand. Type yes if you understand. I'm not seeing your yes, so yes, yes, yes. Yes. Type yes. If you understand this, type yes. Shall we continue? Type yes if you understand. Type yes. All right. Beautiful. Aha. So that is good. That is good. Okay. Now let's look at the second one. The second one says B is a set such that x is a natural number, fine, and x is even. X is even, and x must be less than 15. So you know natural number start from what? 1. The natural number starts with 1. So, and 1 is not even. So that means we start with 2. You cannot pick 1 because we are told that the element must be even. And the element must not be up to 15. So 2, 4, 6, 8, 10, 12, and 14. So these are the elements of set what? Set B. Are we following? Okay. Now for the element of C, set C, we are told that set C has element x, but 4 plus x is 3. Let's check whether we can list the element of set C. Let's first calculate 4 plus x is 3. Okay, so that means x will be 3. Take 4 to the other side. You know it is plus 4 here, become minus 4. So x equals to 3 minus 4. That's what? Minus 1. You have 3 naira, you borrow 4 naira. So you are holding someone 1 naira. So x is equal to minus 1. And from this definition, from this property, x must be a natural number. But unfortunately here, x is giving us a value that does not belong to a natural number. So in this case now, the set for x for this C is empty. So C has what? Empty set. Or doesn't have the elements. It's not possible here. So it says C is empty. C does not conform with the property that it was given. So the element of C is empty. Okay? Please, I want to see you typing yes if you understand, so that we'll be able to continue. Type yes if you understand. Type yes if you understand. Type yes. Let me see your yes, please. Let me see your yes. You have to be active. Type yes. Type yes, please. If you understand, type yes. Type yes. I'm waiting for your yes. Oh yeah. Type yes. If you understand, type yes. Okay. Shall we continue? Shall we continue? Okay. Now let's continue. Good. Let's continue. This we have just started though. We have a long way to go concerning this set. So let's be attentive and let's try to be responsive. If you have any challenges, let me know fast. If what I'm teaching is not clear, let me know so that we're able to go back. Okay. Now let's look at difference of two sets now. Set differences. Difference of two sets. Difference of two sets. What do we mean by difference of two sets? This is a very interesting area that you need to understand as well. Okay, let me write A minus B. What does this mean? This one simply means a set of element X such that X is in that A and X is not in that B. That is the meaning of A difference B. Okay, now I will give an example now. Let A be, let me have a set A, which is a set of 1, 2, 3, A, B, C, D. Okay, and we have a set B, which is a set that has a minus 5, 1, 2, A, B, minus 1. Okay, now we are asked to find A difference B. Now, don't forget, A difference B means A minus B. When you see this notation, it means there is an element in the set A which is not in B. Now, looking at this A difference B, what are the elements in A that are not in B? Just look at element B. What element do we have in A that are not in B? That's the meaning. We have 3. 3 is in A, but it's not in B. Yes, we have what again? You can't pick 1 and 2 because they are in B. What again is in A that is not in B? We have C is in A. It is not in B. Good. We have D is in A. It is not in B. So these are the elements that are in A but not in B. Okay. Now let's find B difference A also. These elements in B that are not in A. Minus 5 is in B. It's not in A. Beautiful. Then 1 is in A. Yes. 2 is there. Yes. A is there. Yes. B is there. Yes. Minus 1. There's minus 1 is in B, but it's not in A. So these are the elements what in B which are not in A. Can we say they are the same? They are not. So A difference B is never the same as B difference A. Okay. Now there's another difference that is called symmetric difference. Symmetric difference of two sets. Symmetric difference. Symmetric difference of two sets. Let's look at that also quickly. Symmetric difference of two sets. Symmetric difference. Please, if you are enjoying this class, type yes in the comment section. Type yes. If you are enjoying this class, type yes. If you are enjoying this class, type yes in the comment section, please. Type yes. Type yes. Type yes. If you are enjoying this class, type yes in the comment section. Type yes. If you are enjoying this class, type yes. If you are enjoying the class, type yes in the comment section. Okay. Good. Now, the symbol for symmetric difference is A. You will see this symbol like nabla, but this is delta, capital delta. A difference B, asymmetric B, asymmetric difference B. That's the meaning. Asymmetric difference B, which means A difference B union B difference A. That's the meaning of this. Okay, let's look at an example. An example will make it more understood. Let's A be equals to 1, 2, 3, 4. That is, A is a set of elements 1, 2, 3, 4. Okay, and B is a set of elements 3, 4, 5, 6. Okay. Now, suppose we want to find asymmetric difference B. Asymmetric difference B. How do we find this? First of all, we have to find A difference B. Okay. So A difference B, these are elements in A, but which are not in B. There is 1 in A, fine. There is 2 in A, but not in B, fine. There is what again? Nothing. So we have only 1 and 2 in A, but not in B. Beautiful. Okay. Now, what about B difference A? That is elements in B, but not in A. 3 and 4 are in B, they are in A also. 5 and 6 are not in A, but they are in B. 5 and 6. Beautiful. All right. Okay. Now, A symmetric difference B, we have what? A symmetric difference B, which is what? A difference B union B difference A. That will be what? A difference B is what? A set of 1 and 2 union B difference A, a set of 5 and 6. So when we bring them together, we get what? 1, 2, 5, 6. So A symmetric difference B is equal to 1, 2, 5, 6. I think that is that about that. Now let's now go to set applications. Application of set theory. Application of set theory. Are we following, please? Are we following? I want your comment. I want your comment. Are we following? 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 I guess we are following. Okay. Please, your comment. Are we following? Let me hear from you. Are we following? Are we following? Yes, are we following? Are we following at all? I want to hear from you. I'm not hearing from you guys. Oh, what happened? Are we following, please? Let me hear from you, please. I want to hear from you. Is the network of your hand there poor? It seems the network is poor. It seems the network is poor. Huh. Oh, the network is poor. How's the network there, please? How is the network there? How is the network from your hand there? This network is terrible. The network is bad, poor, very bad, very poor. The network is good. We can move on. It is very poor. The network is very poor. Poor. The network is okay, good. I think the network has to do with where each of the students is. Some might have poor network, while others will have a better one. So the question is, please, can you see the board clearly? How is the network from your hand there? Let me hear you say something. Like, I mean, let me see you make a comment in the comment section, please. In your comment section, please, I want to hear from you. How is the network? It is not clear. It is not clear at all. Very bad. Okay, I should continue. Not clear. Blurry. How is it like this? It's not clear. Let me try and see if it can be. How about this? How about this? How's the network now? I think I've adjusted the focus of the lens now. How is it now? It's not too clear. It's not clear at all. Very poor. See poor. You know what? Let me change the network, please. Let me change the network. Give me a few minutes. I will change the network now. I will change the network now, please. Apologies.